Okay. In Java, like you are compiling the code, okay, and then you are creating the jar, and then you are running it. Similarly, you will be doing in the Scala also. Actually, Scala also run on the JVM environment, like how Java runs on JVM environment. Similarly, this also runs on the JVM environment. You will create the bytecode. You will compile it. You will create the bytecode, and you will run that bytecode on Java virtual machine. So basically, in Scala also it will run on the JVM. Like it will run similar like how Java code is run, but it is different from Java. But you can use Java live some of the Java libraries also in the Scala, and Scala libraries are also while working on the Java you can use it, because both are like working converted. You will be converting into the bytecode and then running on the JVM. So both way it can be worked. If you want to use some libraries from here to there, you can use. So high level programming language for JVM.
Okay.
Uh, as I told, Scala is also running on Java virtual machine. Okay, it is designed to run on the virtual machine. And as I told, like it means that you can use Java libraries, tool, and framework in the Scala. Okay, and Scala codes get compiled into when you compile Scala code, it will compile into the bytecode. In Java code also is compile into bytecode. JVM Scala code will also compile into the bytecode. So it means that you can, like how Java can be run on any platform. Okay, and it can be moved to any platform. Similarly, you can run Scala also.
Okay.
And we call it high level language because it provides you abstraction and feature which allow you to like it provide more you if when we go about the oops, if you know, do you know about abstraction?
About extraction?
Yeah, abstraction in this oops concepts and all.
Uh, Not much familiar actually.
Okay, and anyway we'll go that. So basically it provides the abstraction and the features which allow to focus more on the logic and less on the low level details like memory management and threading. All those things you don't have to worry about. It will give you the abstraction on top of that. We'll see that.
Okay.
And it combines, so Java before Java 8, okay, Java was come purely object oriented. Oops. Okay, oops, we were telling, right? Oops concept like object-oriented programming it was. After Java 8, it also started supporting the functional thing. Okay, but Scala is the functional programming. Okay, uh, we'll see that why we are calling it functional programming. But after Java 8 also it from use after Java 7, or I will say with Java 8 they also started Java also started supporting the functional programming. But it is not the functional programming, it is still the object oriented programming. But Scala has both object oriented as well as functional programming. Okay, when we call it functional programming, we call the function as a first class citizen. Means you can, once you write the function, you can pass the function to a variable, you can pass them as argument, you can return the other value. In the Java, first class citizen are like integer, string, array, because you can return this, you can pass this, you can return this, you can pass it to the functions and all, you can return it. In the Scala also you can return the integer and string and all, but you can return function also, you can pass function also to any argument. So that's why we call it the functional programming.
Okay.
It also supports, we'll see high order functions and all it is supporting, we'll see about that. Now statically typed with type inference. So what it mean by statically typed is like, so this I have told you about the compile time and type safety, right? In the Scala Spark, in the like
Yeah.
data
Yes. Yes.
and data set. So similarly, this also it will also check the all the types and all during the compile time. So
Okay.
this will yeah, that's we call it the statically typed. Whenever any language like Java is also a statically typed language. If any language is statically typed, means it will look at every variable and expression and compile time, and it will try to see the types and all. Okay, so this will help you like early catch of the error. Okay, so if you do those things at the compile time only, it will help you in catching the error. Now, type inference is like in the Java and all, right? You have to give. Let's suppose if you are providing or defining anything for any variable, you have to give its data type also. Okay, but here like this you will write in the Java, but in Scala you can directly write str equal to abc. Okay, and Scala will automatically deduce what is the uh, variable type or the type of this uh, variable. Okay, you got this or not?
Yep.
So you don't have to define the type. If you don't means if you define it's well and good. If you don't define in the Scala, it will automatically understand that okay, this is a string. If you write something like a equal to 1 in the Scala will understand that okay, this is anyway we have var and val. We'll look at that. But let's suppose you mention that val a equal to 1. So in this way, Scala understand that it is integer. Once you
Okay.
write val a equal to a, then a Scala you don't have to provide the data type. Here you yeah, but in the when in the Java you have to provide the data type also, that what is the variable type. But in the Scala you don't have to.
Okay.
So actually, so this is created by like this Martin Odesky in 2004. This is recently launched, I would say like 20 years before, not recently, but this is the new language. And also these are the company which are using it.
Okay.
So as I told you that Scala, the two, three more important thing is like Scala is designed for both functional as well as object oriented. And we call Scala as the functional programming. Why? Because function is the first class citizen. For with the first class citizen, whenever we say the first class citizen, it means that we can assign that to a function. We can assign that to a variable. Let's suppose that you have a variable a, right? So in the variable a, you can write any function. Okay, you can write any function, you can assign that. So that's why, and you can return in any program, you can return function as output. Okay, so those things can happen. Similar, but in the Java, what is the first class citizen like string? In the most of the Java programming, you will see the return type is either string, integer, array, something like that. Okay,
Okay.
and Java after Java 8, it started supporting the functional feature. Okay, like what the functions support functional programming concepts are. It supports some of the functional programming concepts, but it is not the functional programming. Okay, so these are few things. I think it has only things which I told you: Scala, functional programming, design program, both option FP. Functional are truly first class here. You can define anonymous function. Function can be assigned as a variable, can pass, return. These things we'll see once we look at the
Mm.
function. Uh, Now here it is like immutable by default. Okay, yeah, I have told you about the immutable things, right? means you cannot change it. We
Change.
in the RDD also we saw that RDD is immutable. So in Scala is immutable by default. So what benefit it is giving you? Uh, Thread safety and concurrency. Okay, in the thread safety, if it is immutable, then only one you don't need synchronizations and lock and all. If you don't know those things, then we'll look at that. We have the threading and synchronization locks and all those things.
Okay.
So uh, okay, now just look at what is this primitive. Okay, unlike Java, Scala does not have primitive. So in Java, primitive type is like a basic data type, like int, not integer, but the int, then
Okay.
double, boolean, char. Okay, these are the primitive data type. Actually, why they exist? Because they are fast, okay, and it is use less memory. So that's why it is very core to the Java performance. When you use these things, it will be faster. But downside with this is like they are not object. You cannot call any method or them or anything. So you have wrapper on the integer int, which we call as the integer. So you can call any method on top of the integers and all.
Okay.
Expression oriented, like you have in the Java and all, you can write the if else, okay, and then you do some logic on it. But in the Scala, you can assign it to variable. Let's suppose val equal to, so you are doing something. If this is, then you are giving 2, else you are giving 3. So in this way, it can return you the value in if else. That's what it is mentioned here. Anything, almost everything in expression, if match, try, return a value. But these things won't happen in the Java. You can write the logic in the if else, but here you can return the value also. Scala code are given to compiler, it generates the Java bytecode, and the bytecode runs in JVM. So these are two things. Java is the compile language. This is also one of the important property or feature of the Scala, like where you can write anything and you can return it. Like if I give you one example, in the Scala, okay, you can directly write like val abs equal to, let's suppose we have one value x equal to 0. Okay, so you can write like if x is greater than 0, then x, else minus x. Let's suppose you wrote this code. Now you are returning this value of x or on the basis of x. What it will return? It will return minus 0, right? Okay, anyway,
Yes.
minus 0, it cannot, this program is wrong. Let's suppose we give you 1. Okay, if we give it 1, then it will turn it as x1. If I give it as minus 1, it will return it also as 1. Because I am telling, if it else return minus 1 into minus 1, it will be plus 1. So minus 1 into minus 1 equal to plus 1, right? So that's why return. So anyway, this is, I just want to show you that you can return if a statement output into some variable in the Scala. Now, it supports some of the data types like int, double, long, float, sort, byte. These are the data types which are supported by them. It has the unit. Okay, like you
One
have a
one
void.
question. Sorry. It is primitive you mentioned, right? Scala is primitive. Is not in the previous slide. Is the okay, does not have primitives.
Yeah, it does not have primitive.
It means int double. Those are not supported. I mean, not supported means not used.
No, these int double, yeah, int double are not supported, and also like, but you have these data types here. see, there are two things. Uh, Wait. So you are telling that you are telling this about these int double. Okay,
Yeah,
these
yeah.
supports it is supporting these things. These are the if you have number, so it don't have primitive like it don't have any primitive data type like how it have int and all. Okay, so you have int, you have integers also.
Okay.
Okay, but these are the primitive. Though int and doubles are also in the Scala, but these we don't call it as primitive.
Okay.
Okay, see in the Scala, in the Java, you have int. This is the primitive, but on the this we have wrapper, which is called we call as an integer. Okay, but in the this is primitive, this is wrapper on this. But here it is the data types in it, but this is not the primitive. You can apply any function on this, any method on this up top, double, long, float, and these things.
Okay.
Okay, so you have void in Java, you know about it?
No. Wide. Okay.
That whenever you don't want to return anything from any function, or you just write void. Are you aware
Wide.
of
Wide. Okay.
this thing? So in how you have void in the Java, similarly you have unit in the Scala. When you don't want to return anything from any function or anywhere, you just use void return. In Java, we use void when we don't want to return anything. In Scala, we use unit.
Okay.
So regarding your these things, like I told you, these are not the primitive. Okay. In the Scala, we have int, which is primitive, and wrapper on top of it, which is integer. And you can apply any object on top of this. Okay. Uh, Sorry, this we any method on top of it, not object. This is actually object. Any method on top of it. Okay. So, but in the Scala we have int, double, and all. These are not the primitive. So in the Scala these are the objects. You can apply any method on top of it. Let's suppose that if I write, let's suppose I write val a equal to 3. Okay, and I can make it a dot to string. Okay, this is allowed in the Scala. If you try to do it, it will let you do that. But if you similarly, if you try to do something like x equal to 3, okay, here let's suppose that, okay, we have given a, right? Let's suppose a equal to 3 here, and if you try to do a dot to string in the Java, it will give you error. It will tell you that int is not an object. So only methods can be applied on the object. So twisting a kind of is a method which you are applying on the object. So here it is the primitive type. So it is not object. You cannot apply it. But in this Scala, everything is the object. So you can apply it. It is not the primitive. But similarly, if you instead of integer, if you make it instead of int, if you make it integer, this will be allowed. Clear with this?
Yeah.
Those two are similar by the name, but actually different by their functionality. Integer, int, double, all are object here, but in the Java, int is primitive, integer is object.
Sure.
And one more thing, as I told you, that if you want declare variable type, like here I have not declared variable type, right? But in the when I was writing the Scala code, sorry, Java code, I have to define the integer type.
Okay.
But here I have not defined. So if you don't declare the variable data type in the Scala, it will make the guess of this, that what is the value, what is the not the value, but what is the data type of the value. But it is better in the production, or mostly we try to give the data type with this But if you don't give the data type, it will automatically understand what it is. Now let's just try to understand this val and var. Okay. So val is immutable. So in Scala, whenever you will write or assign, define any variable, you have to either use val or you have to either use var.
Okay.
So val is immutable, var is mutable. Okay. Uh, if you give any thing like, let's suppose val a equal to 3. Okay. And then if you try to do a equal to a plus 3, if you try to do this, not the b, if you try to do a plus 3, this will give you the error. Okay, that you cannot change. So like this, it will give you the error, can't be changed. But if you give anything like, if you write the same program where a equal to 3 and then you write a equal to a plus 3, okay, it will return you result as 6.
Okay.
Okay. So val is like immutable, you cannot change it. But var is mutable, which you can change it. One more thing, if you want to declare anything, okay, let's suppose that you want to define something which you will assigning the variable later, right? In your program, you're writing something and you want to define something, okay, and but you will be using later. So you can define something like this. We call it a wildcard operator. Hyphen. Okay, we call it a wildcard operator. You can use it while defining your variable. So let's, if you see in the example, I have defined variable here and then as the wildcard like hyphen, and then I'm using this.
Okay. While running, we can give the value.
Yeah, let's suppose that in the programming, I need one variable on top of my program, okay, and maybe I will use it later at the end or somewhere. So I will define it on the top, okay, and then I will use it at the big later part of that. Means this is a way where you want to declare a variable without initialization. See here, when I declared, I wrote a equal to 3, right? But let's suppose I don't want to declare, I want to declare, but I don't want to initialize it. So I will write like way while a equal to underscore something like that. Maybe I will do something and then again I will assign a equal to 3 and then I will use it. Lazy initializations. You remember about the lazy evaluation in the Spark, where you until unless you don't perform action, it won't do the things, right? Transformation and
Yes.
all
Yes. Yes.
that we call as the lazy evaluation. So Spark in Scala also we have like lazy initialization. Okay, when you want to delay the initialization of some variable until at the point where it is consumed by your application, you can define it something like that. Lazy val. Like if you assign anything for val, if you write lazy, it will be initialized as the lazy. Like it when your application consuming it, then only it will be giving allocating memory and all. Let's suppose you define it, but you are not using it. Okay. Let's suppose you define but not using, then memory won't be assigned to it until unless you use it, and you this Scala won't be providing the memory to it. Let's suppose the difference between val a3 and this. If you give val equal to 3, memory will be assigned to this. Okay, whether you use it or not use it. But if you give lazy variable initialize only like this, let's suppose you wrote lazy val b equal to 2. Okay, you write something like this. In this case, memory won't be assigned to it. If you in the program somewhere you are trying to use it, let's suppose b equal to b plus 2, or let's suppose c equal to b plus 2, something like that, then only the memory will be assigned to this. Means memory in the store means it will be stored somewhere into the memory, right? When you define some variable and all, it will be stored that okay, b is something which is stored, uh, variable b which value is 2, that is stored into the memory. So if you write lazy, this memory won't be given to it until unless you use it somewhere. Got the thing?
Yeah. Yep.
Okay, so it has expression. Directly you can use it. Like these are the some expression like arithmetic operations. It is it has comparison operation, logical like and or not.
Okay.
Okay. So in this way, in if you see this example, right, val 3 plus 4 equal to 7, and here val is equal sum equal to this, right, equal to this is the equal to operator. So here it will, what will be the result of this? It will be val is equal to true, right? Because sum is also 7, this is also 7, and this is not equal to, this is equal to operator. So
Okay.
this is a comparison operator. If you see, right, this is the comparison operator. So it will return you true and false. Wherever you compare, it will return you the boolean, either true or false. If you like, let's suppose that if you are giving if 3 is greater than equal to 4, right? This will return you either true or false. It won't return you any value. It will return you either this is true or false.
Yeah.
So like, let's suppose you wrote something like this, and if you want to give some other logic, this is the and. If you want to give any other with the logic with or, then you will be using this, and not is this. That is the three things here. Now, let's just look at string interpolation. Okay. This is we will be using whenever string interpolation, whenever you have to print anything. Okay, you are adding any logger or anything, or formatting any variable. That time we will be using these things. Uh, you have, let's suppose this two variable you have defined, right? And in the log, you are here you are printing, but in the log we are using logger, okay, to print the log. But let's suppose I'm printing it. So you have two way. Okay, you can write this in this way only. Like if you, let's suppose I want to print this name and age. Okay, I will print like, I can print like this also. Print name. If I give like this, name and name, okay, it will return you like this. Let's suppose I give, okay, it means that ln means next line. If you write print ln, then it will print into the next line. It will leave one line and then it will write, give you, it will print you. Let's suppose you wrote two thing, right? Print A, and you wrote print B. If you write something like this, it will give you result like this, AB. Okay. But instead, if you write print ln A, print ln B, it will give you result like this. It will print to the next line.
Okay.
That's the difference between print ln and print. Now, if you write print ln and name and then comma, and then let's suppose you have, I'm using name from here, right? Which I have defined. Let's suppose person name is, okay, I write something like this, and then I give comma, and then I will give the name. This name is this name, this name. So it will print you. It will also print you the person name is and then the Alice. Okay. But the other way to print it like this, and string interpolation, this is very useful format, and it is easy to write and all. Let's suppose if I have to print something like this, I will give the S for the string. Okay, and then I will write like this, and I will use the dollar. Okay, if I write the dollar, I instead the variable name I will give some like this. There also variable name I will give like this. Then automatically it will understand and it will return you the result. Go through quickly, then we'll look at it uh, practically. So similarly, you have percentage D, percentage F, and percentage of we saw, right? So these, when you need to print any integer, you can write like this. If you need any double or float, you will use percentage F. These are just to print, okay, just print style formatting. It is nothing like that. Nothing more than it is related to only whenever you have to print anything, or you have to log anything in the logger. If you want to print anything, that time you will use this formatting. This we call as the formatting thing.
Okay.
Now, let's suppose you have to print things where you have the backslashes, front slashes, some. Okay. So if you want to print this, then you will use the raw, like how you have the percentage s. Okay, sorry, s. Then you have f. Then d. Similarly, you have raw. Okay, if you have backspaces and all, backslash and all, you can use the raw to print it. If you see, the output will be something like this. But if you try to print it without raw, it will give you the error.
Well, I backslash won't be there without draw.
No, see, if I write like this, if I try to print this, it print give me the output this.
Okay. Okay.
So it is no not escaping. So if you give these things, it will print it. See see this example with the normal S interpolator. If you try to do this, it will print like this. Okay, it
Oh,
it is
okay.
expected. This is a new line. Okay, so okay, this is the wrong output. This word should have come in the other way, like hello and then world. Okay, maybe I have pasted it in the. It has not pasted in the correct way. So it will come in this way, hello and world.
Okay. Okay.
And next, and if you try with the raw, it will give you in this way.
Got it. Yeah.
Okay. Now we have control structures. Okay. Control structure means for loop, while loop. Okay. Those we call as a control structure. So we will look at like how it is flowing on a look at the looping examples and all. So what is the control structure? Like it will help you in constructing the flow of executions, or it will help you in making the decision on branch logic. Like if let's suppose a is greater than 3, then do this, else do this. So it will help you in making the decisions, right? And there are in the Spark, sorry, in the Scala, we have if else, multiple if else, nested if else. Then we have while loop, do while loop. We'll see the examples of everything. And then we have pattern matching also. This is one of the important thing in the Scala. Pattern matching, one important feature of the Scala, where writing the program will be easy when you have multiple statements to match with. So okay, like these are just the statement, like core building block of algorithm, enabling loop and iteration. So if you use the while loop or for loop, it will be having the loops and all. We'll see the examples of all, then we'll understand more. So as I told you, it has the multiple thing: conditions, if else, pattern matching, looping, block expression, for loop and all. And one more thing, if here if is an expression, I showed you one example, right, where val abs equal to, if you write if x is greater than 0, then abs uh then return something else, don't return. Like with this, what I mean, in the expression also it will return. So it is not just a control flow, but produce a value. With this, what I mean is, like, let's suppose, let me give one example. Val temp equal to 15. Okay. Then temp means, let's just temperature. Okay. And I want to print something. On the basis of this, I want to print. So you can write if else statement here. If temperature is greater than 20, return warm, else cold. Let's suppose something we have. So in this here you can see that in the if you have to write in the Java, okay, then what you have to do is like you have to define a variable. Okay, let's suppose I define the variable.
Okay, here. Got it.
Let's suppose you defined as the weather string equal to null on the top. Okay, then you will write if, or let's suppose you have temp here also, temp integer equal to 15. Then if you write here, you have to write if temp is greater than 20, then weather equal to warm, else weather equal to cold. Okay, you have to write something like this where you have to define a variable and then you have to assign it, right? But here you can directly return from the expression. Here you are also using the expression, but you are returning it to some other value, some defined variable. But here you can directly assign it to the this expression can be directly assigned to a variable.
Okay.
Got this or not?
Yeah, I got it.
I told you that you can have the nested expression here.
Mm.
Okay, and you have match expression. We'll see the match expression and match with guard. Guard means you can put the condition like if and all. Okay, block expression actually, this is also generally we use to write in the Scala. Okay, let's look at this block. Okay, and in the block you wrote at the end a into b. So this will be returned as your value in the result. You write in the block expression with the curly braces, and whatever the you return at the that will be returned into the result, the variable what you have written here. This we call as the block expression. The value of block is the value of its last expression. Let's suppose you are doing many things inside it, okay, and at the end whatever you return, you will it will it will assign that value to the result. So this we call as the block expression. This is actually the some way how you can write the programs and all into the Scala. But these things you cannot write in the Java.
Okay.
This way you cannot write like block expression and all. Okay, after that we have for loop and all. Let's just look at some programming. Okay, then
Okay.
we went whatever we have studied. Let's just look at the programming. Then we'll move further. And also, I expect you to at least practice that programs.
Yes, yes. Can you please? Okay, the basic things, right? For the star, which you mentioned previously in the slides.
Yeah, those things.
Okay.
So you can write in the Scala also, or I would say in the Scala IntelliJ also you can write like this. You can create after installing this or setting up this. You can okay, why this is you can have a worksheet. Okay, if you create a worksheet from here like a Scala worksheet, you can create, right? And
Okay.
once you create the worksheet, you can whatever you will write here. If you run it from here, you will see the output.
Okay. This is intelligent only. I
Yeah,
mean,
this is intelligent. And the similarly, the other way is like as I told you, you can write on the terminal also. You can write it here on the terminal a equal to one. Oh. See, you cannot directly write the a equal to 1. You have to give the val or var. Then you can write val equal to and then a plus b will return you the result. Similarly, in the similar way, whatever you are seeing here, in the same way you can do on the worksheet. And the worksheet on IntelliJ. Similarly, there are two way. In the worksheet, what the difference between writing in the worksheet and the programming is like in the worksheet, whatever you write, you can see the output there. But if you write in the Scala file, you create a Scala file, and if you write the program in that way, in this worksheet, whatever you write, you can see the output. But if you create a class like this, okay, if you try to create a class like this, and if you try to run it, okay, it will see it is first compiling. See, you're executing pre-compiled task. It is compiling, then it will run it. If it does not find any issue in it, then it will run it and give you the output. Correct? See, if it compiled, then it is running. But here in the worksheet, if you write, you can directly just write and run it. It will give you, it will run it and show you the result. So this is for practice and all. But whenever you have to write the code in the Scala and all for the production ready, you have to write like this. You have to create the demo dot, let's say, the Scala. The extension is dot Scala. Here extension is dot .xc. So this is worksheet. It
Okay.
is similar like how you have on the Scala REPL, okay, where you write on the terminal and you see the output. Similarly, you can see here also. But if you write using the extension dot Scala, then this will compile it. So it will take time. So for that's why we are just for the practice and all, we will be using worksheet. And when we write the actual program on the Java, Scala and all with the Spark, we will create something like this and then we'll write our program. So I would suggest once you set up your these things, you work with the worksheet. Just go the right click, new Scala worksheet. Will create new and you can practice here.
Okay.
Or else on the Spark, if you write a Spark cell on the terminal, there also it will open the Scala terminal. There also you can practice the Scala thing.
Okay.
Okay. So let's just start with. So we started with the data types, right? It has data types int and so as
Yes.
I see here, I have not given the type, right? But it actually by itself it did reduce the type,
Yes.
right?
Yes.
So the if you but in the Java and all, it won't be happening. You have to define the until unless you don't define the type, it will give the error. Now, here you can define data type also. See in the str, I have defined the data type, right? But here I have not defined. So if I let's suppose if I write and I remove it, okay, and I write the str1 and I run it, right? Let's see here. It automatically reduced it, right? It automatically get the data type of the string. You can define also if you want. You can define also. It's data type. Here, if I want, I can define, and if you don't define, it will automatically try to understand what the data type is. But in the production and all, we try to define the data type also,
Okay.
but not necessarily. And one more thing, as I told you, let me just go to the slides and take the things. Okay. Now, in the variable, I told you about the unassigned variable, right? Where let's suppose that you have this string. Okay, you have an assigned value and you want to use it. If you leave it like this, it will give you, it is giving you error, right? You
Yes.
cannot, if you are defining any variable, you have to assign with something. That is true with the Java also. But in the Scala, let's suppose you just don't want to define any variable or provide any value here, but you will be providing it later in your program somewhere. You can write it like this. This we call as a wildcard operator. Okay.
Okay.
Or it is not taking over. It is giving you unassigned variable. So automatically it will and let's suppose now I want to use it. I did something, let's suppose I wrote something and after that I want to use this variable. Then I can use this unassigned variable equal to 3 plus 2. Let's suppose some program. Oh, it cannot because here I have given the string. Give us the input. Now it assign the value to it.
Okay.
And also like if you define it as integer and if you try to give the string and all, it will give you the error. See, this we call as these are the error and the Spark data frame. Okay, it will see it while running, but in this data set and all, it will find it at the compile time only. Here also, if you see, it is giving you the error, right? So so this we actually here it is giving you the error because we are in the IntelliJ. Okay, but if you write it on the Scala cell, okay, it won't give you the error, but once you run it, it will give you the error. So this is the good thing of the compilation program that it will find these type of error or most of type error and other errors during compilation only.
Okay.
And if I make it a string, we go. On about the lazy evaluation, let's just look at it. Okay, are this right? Val string this. Let me just give it a new name. Lazy str. Okay, let us give this name as lazy str and let's just run it and see what is up. Oh, I have not given it lazy. Okay. See now it have assigned the value, right? String,
Okay.
but now let's just give it lazy. Why it is complaining for this? Oh, okay. Because I have given that. Okay, the syntax would be like this. You have at the beginning you have to give the lazy. Now
Okay.
to run it, see we saw that it has assigned the value. Or let me just take it. Get one more. See here, it has assigned the value memory to it, but it has not assigned any value to it.
Okay.
Okay, but let's just use it. See, once you use it somewhere, then it will assign the it will actually currently it has not assigned it. But once you will use it here, lazy str value, this value you use it, then it assign the value to it. It will give you the final result. This plus is actually appending the new string to it. So ABCA it is give returning you. Now let's just look at this example which I told you about the print. Okay, print A. It is to why it is returning at the same place. But the reason between them is that it is give you the this AB will be print in the one line. Okay, we look at it. I'm not sure why in the SC in the worksheet it is giving like this. But difference between print and println is like
Yeah.
it
Got it.
print in the two things. Okay, now what are your things are it? So now let's just look at uh, unassigned, so lazy variable is expression and operator. Expression and operator, like I told you about the arithmetic things and comparison and all, that you
Yes.
like for the programming. Now just look at some example from the string interpolation. Okay. In this, let's suppose that I have given one. I'm taking the same example from our slide.
Uh, okay. Here, person name is there, right?
I
Um,
gave this as a
okay.
while printing. I wrote this.
Okay.
Okay, and I put it into the inverted comma. Let's suppose that in the logger and all also you want to print it. So, but in the logger we will use the logger. There is some library of the logger which will use the print. But wherever you have to print it, you will write something. So, what we are trying to learn is you will format it. Okay,
Okay.
with the string interpolation, how you will format. See, this is also one way to write it. But
Okay.
you have many variable. Okay, lots of variable in that. And then it is easy to write in the way of string interpolation. So let's suppose that I have to print the same thing. Okay. Then what I will do is like println person name is. After that, what I will do, I will just write name here. Okay. And if I try to run this also, it will give you the result. Correct. Okay, why it is not giving this? Oh, sorry, I missed to write S here. See, this is also giving you the correct thing, and this is also giving you the same thing.
Okay.
But why this is coming?
Okay. Braces. Okay.
I know. Yeah, these braces. Okay, anyway, leave it. We will be using this only. This is actually we are using the production. Maybe I have not using it much, so I'm not sure like why this
Okay.
is. Okay, I will look at it why this is printing the braces. So in the production and all, we will use the string interpolation only. The reason,
Okay.
let's suppose if I have 20 variable, right, this, right, and I want to print it, I can directly here, if you write, let's suppose you write here, age is uh, dollar age. Okay, if you write like this, it will print the age also. Here also you can do like, see here also you can write in this way. Okay, this is also a way to write it, but it is when you have lot of things, then it is difficult. It is easy to write. See here, this is easy to write. Like here, you have to give the double inverted comma, then you have to give the plus and all. You have to take care of these things. If you miss anything, it will give you the error. And also in the formatting, like see, that time I tried to write it and I missed this, right? I write something like this. Then it was not readable. So it is easy when you write in this format. So basically, this is for the printing and formatting the variable. So string interpolation is one way. And whenever you have to write, there is format string f interpolator also. There you will be using f. Here we used s, right? For the this one float and all, we will be using f. Let me just give you one example. Let's suppose that I have val height equal to 1.7523. This is I am copying from the slide. And then you have println. Okay, and now this is float, right? And you have to print this here. When you have string, you did like this. Here with the number also you printed like this, but here you have float. Let's just see what it is doing once we try to print in this way with the s interpolator. When you give the dollar, it will take the variable. It will understand that
Yes.
this is not
That's
the
right.
string but some variable which you have used earlier. See, it gave you full thing, right? But let's suppose that you just want to print only the two variable, not all. Okay, let's suppose if you want to print the full result, then you can give it. But let's suppose I want to trim it to just a two variable. So in this case, what you will do, instead of writing string interpolation, you will use the float. And with this, you will, after writing this, you will tell it how much you want, like till what decimal places. So to define that, you will use something like this, percentage dot 2f. So I want up to two place decimal.
Okay.
So it will give you the result just a two place decimal, right? This is just the printing style. And let's suppose there is one float interpolation when you will use when you want to trim some value from the doubles and all. Let's suppose if you have this big value, right? You are returning something and you are getting something this value, but you wanted to print only the two, three values, right? So in this case, you can return something like this.
Uh, okay. So in string interpolation, only the
It
example
will
you
return the
mentioned.
full value. Yeah, exact value it will return.
That's it. That's the only usage.
Yes, yeah. See
Okay.
here also, I try to give that up to two variable I am getting, right? And I give this 7.56333, right? It return me 7.1.76. So because the before 5 we have variable of greater than 5. This I think you must have, or I don't know whether you remember this or not. If you try to print some two place value and the third place is more than 5, it will add one to this previous place.
Oh, yeah, yeah.
Okay, so that's why it returns the 1.76.
Yes. Okay.
Okay, and the raw and on, let me just copy the same thing from here. Same example. Okay, it came in the to this one, right? Oh, I think maybe here also it would have been the same thing. Okay, if you see here, when we try to put the hello world, it will give you the two. It consider this as a next line. But if you use raw instead of this s, okay, it will give you the
Everything. Okay.
and over like this. So that's why wherever you want to print some path, okay, maybe somewhere you want to print the path in your program, you can just use the raw.
Okay.
Okay, so now we have control structure and all. Okay, tomorrow we'll see, look at the while loops and other loops. Okay, I would suggest just look at some of the things from the beginning, like val, var, and string interpolation. Only the val, var, and string interpolation is the important from today perspective.